Today we're going to take a look at transformations. Specifically, the transformations we're going to look at are reflections and translations. A transformation is a mapping of every point in the coordinate plane to a new point. Basically, that just means that we're going to take a point in the coordinate plane, in fact, every point, and move them to a new point following some rule. When we talk about a reflection, what we need is a line of reflection. And the first one we're going to look at is the x-axis. Let's reflect this triangle over the x-axis. The way it works is when you reflect a point like A, you go along a perpendicular to your line of reflection, which is the x-axis here. And notice the distance is 3. I go 3 on the other side. And this new point right here we'll call A prime. That prime just means it's the new A, the new location for A. When we do B, we go along a perpendicular to the line to a right angle. We go the same distance on the other side, and that point will be B prime. And then for C, we'll do the same thing. Go along a perpendicular to your line of reflection. Right there's a right angle. Notice that that's 5 away from the x-axis, C is. We'll go 5 up, and that is the new location for C, or C prime. Then we'll connect those points, and the triangle in red is the reflection of the triangle in black. The triangle in black we call the pre-image, meaning before, and the triangle in red, the reflection, is called the image. When you look at those triangles, you can see how the black triangle and the red triangle, that when I reflected it, what it does is flip the triangle over the x-axis. Sometimes a reflection is called a flip. Take a look at the ordered pairs in the two triangles and make an observation. Point A, -9, -3, became -9, 3. Point B, -3, -1, became -3, +1. And point C, -5, -5, became -5, +5. If you look at the ordered pairs, what you see that in the image, the reflection, the only thing that changed was the y, and it became the opposite. We can describe this relationship like this. This transformation took a point xy and made it the point x -y. In other words, in the image, all I had to do was take the ordered pair, the original ordered pair, and change the y value to the opposite, and this describes a reflection over the x-axis. Here's an example of reflecting over the y-axis. The y-axis is our line of reflection. Let's reflect point A. We go along our line of reflection to a perpendicular. A is 1, 2, 3, 4, 5 away from the y-axis. We're going to go 1, 2, 3, 4, 5, and this will be our new location for A, or A prime. Do the same thing to B. We go along to perpendicular, it's a distance of 2. We go 2 on the other side, and this is our B prime. Then we'll do for C. Travel along a perpendicular to your line of reflection. It's 5 units away, and we'll go 5 on the other side. And this will be C prime. Then the last one is going to be D. Along a perpendicular, D is 8 away, and we'll go 8 on the other side. And there is D prime. Let's connect those. A, B, C, D was the pre-image. And the red, A prime, B prime, C prime, D prime, is the image. Take a look at the points again. Notice how negative 5, 8 becomes 5, 8. That's A. B, negative 2, 2 becomes 2, 2. C, negative 5, 1 becomes 5, 1. And D, negative 8, 7 becomes positive 8, 7. We could write this transformation, a reflection over the y-axis, as every point xy ends up being sent to negative x, positive y. In other words, the only thing I need to do to a point is make x the opposite and keep y the same. Keep in mind that you can reflect over any line. It doesn't even need to be in a coordinate plane, although it is a lot easier if we're on at least a grid. Here's an example of a reflection over y equal x. Y equal x, that's the ordered pairs. 1, 1, x and y are equal. 2, 2, 3, 3, negative 1, and negative 2, negative 2. Let's draw that line. When we reflect, we go along a perpendicular. Notice I'm going the diagonal of that square in the grid. So I'm going a diagonal of 1, and I'll go a diagonal of 1 on the other side, and that will be my A prime. I'll do the same thing with B, a diagonal of 1, a diagonal of 1, and a diagonal of 1. 3 diagonals, and I'll go that same on the other side. Remember, you have to have a right angle when you do reflection. The same thing with C. Go along the diagonal. That's 1, 2, 3, 4, 5 diagonals. 1, 2, 3, 4, 5 diagonals. So now I have B prime and I have C prime. Let's connect those. I wrote down all the ordered pairs. Notice again that there is a pattern. Reflection over the line y equal x takes a point xy and sends it to, look at the points, B, negative 1, negative 7 went to B prime, negative 7, negative 1. A, 6, 4 went to 4, 6. And C, 7, negative 3 went to C prime, negative 3, negative 7. What happens when you reflect over the line y equal x is the x becomes the y coordinate and the y becomes the x coordinate. A translation is a transformation that slides a figure in one direction in the coordinate plane. If you were asked to move this figure right 5 and up 3, each point would slide along to the right 5 and then move up 3. This is the B prime, the new location for B. A, go right 5 and up 3. There's A prime. And C, go right 5 and up 3. Connect these dots, and you have yourself a translation. Notice that the figure does not turn at all. It just moves one direction. Take a look at the points. Notice how in A, negative 7 becomes negative 2. In other words, going right 5 increases the x by 2. Negative 5, when you increase by 5, becomes 0. And negative 1, when you increase it by 5, going right 5 increases x by 5, it becomes 4. And y goes up 3, so an A, negative 4 becomes an A prime, up 3, negative 1. And B, the 1 going up 3 becomes 4. And in C, negative 7 becomes negative 4 when you go up 3. We could write this as xy becomes x plus 5, going right increases x by 5, and going up 3 increases y by 3. If I were to give you a point, say 6, 2, and you applied this transformation, you would add 5 to x, it'd become 11, and you would add 3 to y, and it'd become 5. This would make the point 6, 2 move right 5 and up 3. Another way we can transform a figure is along a vector. Here we have the vector -5, 6. It's in component form. See the less than, greater than sign around the -5, 6? That means the initial point is at the origin, and it stops at the terminal point, -5, 6. When we translate along a vector, what we're imagining here is that this vector gets picked up and moved and placed on each point. Each point moves the distance and direction of that vector. A ends up at 2, -2. B ends up at -1, 3. And C ends up at -7, 0. Let's connect those dots. Take a look at the points and notice what happens. 7, the x, became 2. It decreased by 5. And -8 became -2. It increased by 6. Moving along the vector -5, 6 takes a point xy and just subtracts 5 from x and increases y by 6. There's no difference between these two. They mean the same thing. The first example from your assignment we're going to look at is question 7. We're going to reflect this across the x-axis. The x-axis is our line of reflection. So we'll go along a perpendicular. Notice the distance to the x-axis is 4. We'll go 4 units on the other side, and there's our A prime. For B, it's also 4 away. Go forward on the other side, and there's B prime. C, it's not going to move because there's no distance between it and the line of reflection. It's also C prime. D is 1 away from the x-axis. It'll be 1 away on the other side. We always go along a perpendicular, and that's D prime. Connect those 4 points. The quadrilateral in red is our reflected figure. Question 8. This time we're going to reflect across the y-axis. A is on the y-axis. There's no distance between it and the y-axis. It's going to be the same point. A and A prime are the same. B is 4 units away from the y-axis. So you go 4 units on the other side, and that will be B prime. D is 1 unit away. Go along a perpendicular. 1 unit on the other side. That's D prime. C is 3 units away. We'll go 3 units on the other side, and there's my C prime. Connect those points. The quadrilateral in red is our answer. Question 12. This is a transformation that takes the point 2, 4 right here and moves it to the point 2, -4. So we're going that direction. Notice how we're 4 units on the other side. This is our A and this is our A prime. This is reflection over the x-axis. Notice how x stayed the same and y is the opposite. Question 13. Here we have a transformation that takes the point 3, 7, right there. This is our A, our starting point, and moves it to -3, 7. This is our A prime, the image. It moves along a perpendicular to the y-axis and goes the same distance on the other side. This is a reflection over the y-axis. Notice how y stayed the same and x became the opposite. Question 15. We're going to reflect over the x-axis. Let's take one of the points and look at what happens. The point 2, -8 down here, what will it do when we reflect over the x-axis? It's going to go straight up to the x-axis. It's 8 units away. It'll be 8 on the other side. This is our new location. Let's call this A and this A prime. Notice that the point 2, -8 becomes the point 2, +8. A point xy becomes x, the 2 stayed the same, but y became the opposite, x -y. So every one of these ordered pairs, the x is going to stay the same, 2, 10, 6, and 0. Y, though, is going to become the opposite. That's 8, -5, 2, and -7. Question 16. This time we're going to reflect these points in this table across the y-axis. The point -4, 1 reflected across the y-axis is 4 units away to the y-axis along a perpendicular. We'll go 4 on the other side, and we end up at 4. If we call the first one A, it's -4, +1. It becomes A prime, which is +4, +1. Looking at the ordered pairs, this transformation takes a point xy and sends it to -4 became +4. The x is the opposite, and 1 stayed 1, the y stays the same. So in this table, x will become the opposite. That's 4, -5, +8, and -10, and y will stay the same. 1, -7, 0, and 3. Question 20. Which one of these transformations describes the coordinates of a polygon that is reflected over the x and y axis? Let's choose any random point. I chose the point 3, 5. I'm going to reflect it over the x-axis along a perpendicular. Notice it's 5 away. It'll end up at 5 on the other side. So this is A prime, not quite the final A though, because we're going to reflect it over the y-axis now. Notice right now it's 3, -5. When I reflect it over the y-axis, it's 3 units away. It'll end up 3 units away along a perpendicular. This is A double prime, we'll call it. It has coordinates -3, -5. This transformation across the x and y axis takes a point A, which is 3, 5, and sends it to A double prime, which is -3, -5. xy becomes -x and -y. That would be this one. Question 21. Which of the following describes the coordinates of a polygon that is reflected across the line y = x? Here I've got the coordinate plane. I drew in the line y = x. Reminder, that's the points 1, 1, 2, 2, 3, 3, 10, 10, -10, -10. I picked a point just to see what would happen to it. I called it A. It is the point 7, 2. I'm going to go along a perpendicular to the line y = x. I have to go along the diagonals of the grid. That's 1 diagonal, 2 diagonals, and a half. I've got to go a half and then 2 diagonals, the same distance on the other side. Right there it is. This is my A prime, and it is the point 2, 7. It looks like reflecting across the line y = x takes a point xy and it flips them. It makes the x the y and the y the x. That would be this one. Question 27. The point 87 gets sent to 7, 4. X decreases by 1. Think of the horizontal axis, the x-axis. Decreasing by 1 means you're going to the left, so it's one of these two. The y, 7, becomes 4. Y increases by 3, so it's going to go up 3. The correct answer is the third one. Question 28. 9 is becoming 5. 9 decreases by 5. This is the x, so it's going to be going to the left, and that would be 4 units. 9 minus 5 is 4. 8 becomes 9. Y is increasing. It's going to go up. That is 1 unit up. Question 29. Here we have a triangle PQR that we're transforming using the rule xy becomes x plus 4 and y plus 5. X will increase by 4, y will increase by 5. So the point P becomes P prime. Increase x by 4, that's 1. Increase y by 5, that's 4. Q, negative 2, negative 3. If we add 4 to x, becomes 2. And add 5 to y, it becomes 2. R, add 4 to x, becomes 3. Add 5 to y, and it becomes 4. Let's plot these points. Notice that this is a translation. Anytime we write notation where xy goes to x plus or minus a number and y plus or minus a number, it's always going to be a translation because we're either going to be moving left or right or up or down. Question 31. Draw the image of the trapezoid using the translation xy goes to x minus 3 and y plus 4. X will decrease by 3, it will go 3 left. Y will increase by 4, it will go 4 up. Take each point, move x 3 to the left, we'll start here, 1, 2, 3, and 4 up. If that was point A, this is point A prime. My next point, I'll call point B. I'm going to go 3 to the left, x minus 3, decrease x by 3, and increase y by 4. This is my B prime now. Here's my point C. X will decrease by 3, left 3. Y will increase by 4, up 4. That is C prime. And my last point I'll call D. X minus 3, decrease x by 3, increase y by 4. There's D prime. Let's connect those points. We just translated the figure and we moved it 3 left and 4 up. Question 32 is a quick one. Here we have a transformation that is a translation. It's going to increase x by 4 and y by 1. Take these points, increase x by 4. A prime will be 6. Increase y by 1, 6, 5. B prime, increase x by 4 will be 2. Increase y by 1, 7. C prime, if we add 4, x is 0. And increase y by 1, we get negative 5. Question 33. We're going to translate on a vector, the vector 5, 4. Notice that each point will move 5 right and 4 up. This is the same as the transformation xy will become x plus 5 and y plus 4. Exactly the same thing. Increase every x by 5 and every y by 4. We'll go right 5, 1, 2, 3, 4, 5, and up 4. Do that for every point. Move it right 5 and up 4. The figure in blue is our translated triangle. Take a look at the vector 5, 4. If I grab it and move it around, what I want you to notice is that it is the perfect representation of the distance and direction the point moves. Question 35. We're going to translate triangle ABC along the vector negative 5, 1. You just need to realize that translating along this vector will decrease x by 5 and increase y by 1. It is the same as the translation. This is a translation. You're moving left and up. As the translation xy becomes x minus 5 and y plus 1. Take every ordered pair, decrease x by 5, and increase y by 1. A prime is negative 1, negative 3. B prime is negative 10, 6. And C prime is negative 11, negative 2.